Let us see the another example, that scandium-2 is a virtually unknown. Why? It is very important question, because scandium 3d1 4s2 is the general electronic configuration. From this electronic configuration, it loses 2 electron, means it becomes 3d1 4s0. It is only one unpaired electron. It is highly unstable. So scandium is a 2 is a not known, so it is unknown. But it shows scandium 3 plus 3d. I mean, all the 3 electrons are losing. It becomes a vacant orbital, 3d0 and 4s0. So according to the inert pair electronic configuration, just write 1s2, 2s2, 2p6, 3s2, 3p6, 18 electrons. Then 3d0, 4s0. So what attains stable electronic configuration? So that stable electronic oxidation state is 3 plus alone. So I have written here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So in this 10 and here 8, up to this is a inert gas configuration, argon 18 electrons are here. So this is stable. Here after losing 3 electrons, this is all the 3 electrons are lost. So it comes 3d0, 4d0. So I mean 4 is 0 and 3d0, it is a more stable electronic configuration. So scandium will acquire only 3 plus electronic, oxidation state, no plus 1 oxidation state, no plus 2 oxidation. Then chromium, why titanium 4 are stable than titanium 3, titanium 2 and titanium 1. So here titanium electronic configuration is 3d2, 4s2 for first one, losing 1 electron, 3d2, 4s1. So here D alone we should see it is 2 electrons, so I have written 2. And titanium 2, 3d2, 2 electron is loses, it acquires only 3d2, so 2 unpaired electron. And titanium 3. So titanium 3 means losing 3 electron, 2 plus 2 here, 1 here, for 3d1. So it is only 1 electron. And titanium 4, losing all the electrons. So 3d0, 4 is 0. So no unpaired electron. So it is 2, 0, 2 electron, 2 unpaired, 2 unpaired, 1 unpaired. So it is unstable. So there is no electrons at all attaining the stable electronic configuration of inert gas. Here 1s2, 2s2, 2p6, 10 electrons. 3s2, 3p6. 8 electrons, totally 18 electrons according to inert gas. After titanium 4 only, it loses all the all the 4 electrons, 2 from s orbital, 2 from d orbital, become 0, 0. So titanium 4 plus is more stable than this. Titanium 4 is more stable than other things. Next question, why zinc does not exhibit variable valency? So because it has a completely filled electronic configuration, 3d10, 4s2, only plus 2 oxidation state, 3d10, 4s0, attains stable electronic configuration. So it has a only plus 2 oxidation. It cannot be on the next. And molybdenum 6 and tungsten 6 are more stable than chromium 6. Why? Chromium 6 is less stable than molybdenum 6 and tungsten 6 because rule to be followed. If electron does not have radial nodes, node means zero electron density is called a node. So radial sphere. So if electron does not have the radial nodes, then the substance to be very strong attracts towards the nucleus. They are very strongly bonded to each other. So here according to the radial nodes. So radial nodes formula is n minus 1 minus L formula. So n is equal to 1, 2, 3. So what L is equal to 0. If 0 means L is equal S orbital, P means 1, D means 2, and L is equal to 3 means F orbital for this. So for this 3D1 minus n minus 1 minus L formula, just write n value and then L value here minus 1. Here 3D series n minus 3 because n is equal to 3. Because here I have written n minus 1 minus, this is L value, D value is nothing but 2. So what I have subtracted 2. So what n minus 1 minus 2 comes to minus 3. Minus 1 and minus 2 is called as a minus 3. So what I have added L value. So L value for D is a 2 value. So what N minus 1 minus L value is 2 for D series, and then we can write a N minus 3. So what this is N minus 3 for a 3D series, 4D series and 5D series. Now we'll write apply N value. I have minimized this N minus 1 minus L value as 1 minus L value I have written here as a N minus 3, N minus 3, N minus 3, because D for all L value is 2 only. So what minus 1 minus 3 comes to minus 3. So this N value is principal quantum number 3. For this principal quantum number is 4. For this principal quantum number is 5. So what N is equal to 3 for this, N is equal to 4 for this example, N is equal to 5 for this example. Now apply N value. 3 minus 3 equal to 0 and 4 minus 3 equal to 1. 5 minus 3 equal to 2. For 3D series, it has a 0 radial node, and for 4D series, it has 1 radial node. For 5D series, it has 2 radial nodes. So here chromium 3D5, 3D5, it has 0 radial, and molybdenum, it is 4D, it is a 1 radial node, and for tungsten 5D it is a 2 radian. Don't see the electronic configurations and just to see series, 3D series, 4D series and 5D series, and relate to the radial node formula. So radial node is for a sphere and angular node for a flat planar. So if it is a flat planar structure, angular node to be taken. If it is a sphere, means we are supposed to take radial nodes. So here the rule will, let us see the rule. So according to the radian node, very easily lose electron and before and form a +6 oxidation state. Here it is a 1 radian losing electron, it is a 5 plus 1, 6. And here the 2 radian, so it is a 4 plus 2. So which are not close to each other, because whenever the radian value is 0, they are very close to the nucleus. So I already told you, if electron does not have radial nodes, means the substance is very close to the nucleus, so what they will have a very strong attraction. So what if even this, if it is a radian, they are losing the electrons very easily. So what I said, very easily lose electron and form +6 oxidation state if it is a radian values are present. If it is a 0 radian value, definitely we cannot lose the, it cannot lose the electron, because they're very close to the nucleus. So what it is, the attraction is very strong. So for a radian value 1 and 2 easily loses 5 plus 1, 6. 6 electron losing becomes +6, and 4 plus 2 losing 6 electron becomes +6. So not close to the nucleus. So it forms +6 oxidation state. Chromium 3D. 3D series having a 0 radian node. So they are very close to the nucleus. So what it is, very close. So 0, close to the nucleus, attraction is strong, very strongly attracted. So because of the 0 radian, so it is a very less stable. So it is difficult to lose electron and form a +6 oxidation is not possible. Then 0 oxidation state. So thanks for watching, students.